Hey everyone, welcome back. This last video for this week is about how you're going to describe the different important features on a quadratic graph, or in other words, we call that a parabola. So we're going to look at the different parts of a parabola today. So if you remember from the last video, we talked about the ducts and the different expressions we can write to describe the number of ducts in any step or in any stage. And we came up with these three different expressions. And then what we did is we proved that they are the same. So we did that by putting them in Desmos and showing that they have the same graph. And then we also proved it algebraically. So if you're not sure how to do that, go back to the second video and watch that. What we notice is that when we put them in, we get this shape that looks like this. And as you recall, we call this a quadratic function. And a quadratic function produces a graph that has this thing called a parabola. And today we're going to talk about the different parts of that parabola, or important features. Before we look at the different parts of the graph, we're going to just take a look at a couple of different types of preferred quadratic equations. So what you'll notice is, like back here, you'll notice that these all look kind of different, right? They don't all have one way of writing it. They just look different. So what happens is when we get quadratic equations, we get a couple of different forms, and they generally come into these three forms. We got general form that looks like this, which is completely simplified. We got factored form, which has the factors in there. And then we got standard form, or it's also known as vertex form, and we'll talk about that a little more later. But just know that these are the three major forms that we see in quadratic equations. Now, if you remember, in the last video, we looked at those different duct expressions, and then we simplified them to prove that they were equivalent. What I'd like you to do is pause the video right now and see if those ones that we have circled in red, they're all the same. See what type of quadratic equation you think that is. What type of form do you think that is? So what you probably noticed is that all of these, which are all the same, they all kind of look closest to the general form. And they're in general form because they're all completely simplified. We're going to keep coming back to this chart, so if this feels kind of confusing, don't stress. We're going to keep coming back to it, but I just wanted to introduce it today. Okay, next, we're going to move on to the different parts of the parabola. Now, you're going to notice there's a lot of things going on. So we're going to zoom in here. You're going to see all these different parts, and what I would do is take a screenshot of this or pause the video and write this down in your notes so that you have it. But I'm going to quickly go over all of them. So the first one is the Y-intercept. That is the point where the parabola, this blue part, crosses the y-axis. And remember, the y-axis is this dark black line here. So if you look, it crosses right here at this point. That is our Y-intercept. Our vertex is the very lowest or the very highest point of our parabola. We call that a maximum or a minimum, and that's going to happen right here. The X-intercepts are the points where the parabola crosses the x-axis. And what's interesting about these is they have a ton of different names. We call them X-intercepts, we call them solutions, we call them roots, we call them zeros. But they all mean the same thing. They're just the points right here where the parabola crosses that x-axis. The next one is the line of symmetry. What's interesting about all parabolas is they all are symmetric, which means they are the same on both sides. So if you were to draw a line right through the vertex here, and fold that picture in half, it's going to be the exact same on both sides. We call that the line of symmetry, and we write that as an equation. And we'll look at an example in a second. And then the last one is a scale factor. The scale factor is how stretched out the parabola is. And we'll talk about how to find that in just a second. All right, the end of your practice assignment has this thing here. We're going to go through this example so that you can use it as a guide to do the problems on your practice assignment. So the first one we're going to look at is the vertex. We're trying to find a point. The vertex is the highest point of the parabola, so you'll notice it's right here in green, and it happens at point 2, 1. That's the vertex. The next one is the maximum or minimum. Remember that the vertex and the maximum are the same thing. right? That happens when x is equal to 2, we get a maximum of 1, and we write that in function notation. The next one is the line of symmetry. That's the line that cuts the parabola in half. That happens when x is equal to 2, so we're going to write an equation for that orange dotted line like this. X is equal to 2. The next one are the x-intercepts, or the roots, or the zeros. Those are the points where the parabola crosses the x-axis, and that happens at this point, which is labeled as 1, 0, and this point, which is 3, 0. The next one is the scale factor. That's probably the hardest one for students. The scale factor is how stretched out it is. And what you're going to do is you're going to start up here at the vertex, and you're either going to go to the left or to the right 1 space or 1 unit. And then depending on where your parabola is going, if it's facing down like this, you're going to put -1. If it's facing up, you're going to put +1. Sometimes the point will be right here, and if it goes down 2, then the scale factor would be -2. But that's how you're going to figure it out. Start at the vertex, go to the right, and then figure out how high up or how far down you have to go to get to that parabola. And then the last one is the Y-intercept. That is where the parabola crosses the y-axis, and if you look, there's a point right here where it crosses or intercepts that y-axis, and that happens at the point 0, -3. So make sure you try some of these problems. If you get stuck or you're not sure, please come to our class, our Google Meets in the morning, or go into our office hours and we can help you if you just have a quick question. All right, have a good day.